Alright, so this one here is looking at multiplying complex numbers together, but really it's just like multiplying binomials. So in an AC circuit, the voltage E, current I, and impedance Z are related by the formula E equal to I times Z. And we want to find the voltage of the circuit with current of 1 plus 4J amps and an impedance of 3 minus 6J amps. Or ohms, not amps. And so now, again, we know that E is equal to I times Z. So we know that I is equal to 1 plus 4J. Z is equal to 3 minus 6J. So we're just going to multiply these together. Multiplying binomials, just like we were doing earlier today. So 1 plus 4J times 3 minus 6J. We're going to FOIL it. So we got first, outer, inner, and last. So our first ones, 1 times 3, so 3. The outer, 1 times negative 6J, so negative 6J. And then the inner, 4J times 3, so that's going to be 12J. And 4J times negative 6J is going to be negative 24J squared. Now this has a J instead of an I, but it's still the same idea. J is equal to the negative, or square root, of negative 1. So this means that J squared is equal to negative 1. So we're going to simplify this. We can combine like terms with these two. And we can go ahead and simplify the 24J squared as well, because J squared, again, is negative 1. So we have E equal to 3, leaving that alone for now. Negative 6J plus 12J leaves us with just 12J. And then minus 24 times negative 1. So we need to multiply. So that's just going to be a positive 24 now. And now we have one last step where we have this 3, the 24 to combine together. So our final answer, E is equal to 3 plus 24, which is 27, plus 12J. So it's very similar to multiplying binomials. The difference is that whenever you square your variable, in quotations there, the I or the J in this case, then you do have to change it to a negative 1. So the last one for us to work on is dividing complex numbers. So it's a little bit different. So what makes this complex is that in math we don't like having radicals or roots on the denominator of fractions, and an I, remember, is the square root of negative 1. So that means we need to get rid of that. So to do that, we have to multiply by 1, basically, but we're multiplying by something called the complex conjugate. All that means is whatever our denominator is, we're going to multiply by the complex conjugate of it. So that means we change the sign. So 3 minus 2i. So 3 minus 2i. So that is going to get rid of it here in just a second. I'll show you what that looks like. So first we've got to multiply the numerators. So 5i times 3 is going to be 15i. And 5i times a negative 2i is negative 10i squared. Remember again, I squared is equal to negative 1. For the denominators, it's a little bit different. So we have to actually, we got to do some foiling here, right? So we're going to do the first, the outer, let me do this different color, sorry. Outer, the inner, and the last. So the first 3 times 3 is just going to be 9. The outer 3 times negative 2i is negative 6i. The inner 2i times 3 is going to be a positive 6i. And then the last one's 2i times a negative 2i is going to be a negative 4i squared. So now in the denominator we have a 6i and a negative 6i. They're going to cancel each other out, so they're gone. And then we have two instances where we have an I squared. So for the numerator, 15i minus 10 times negative 1. And the denominator, 9 minus 4 times negative 1. So notice on the denominator now we have no I, right? So that's what we want. We don't want to have anything with an I or a square root or a square or root at all. That square is fine, but no roots. So multiplying on the top, we get 15i plus 10. We're going to rearrange that because we don't like it to be in that form, but that's okay. On the denominator, we get 9 plus 4. So we're going to rearrange the numerator, so it's 10 plus 15i. And the denominator, 9 plus 4, is just 13. Now, I'm perfectly fine with you leaving it just like that. However, you want it to be broken apart into its real and imaginary parts. So we're going to break this fraction up into a 10 over 13 plus 15i over 13. Or 15/13 I. So our real part is 10/13. The imaginary part is 15/13. And that's the real solution. Last one is for you guys to do, and then your eggs ticket.